This video will give you some examples from your worksheet that you'll be doing in class. The first one is direct variation, which means some value equals some constant number k times some other value. In this case, number of gallons of fuel, G, equals our k times the number of miles, m. So the next part says if a trip of 270 miles, 270 goes here for m, requires 12 gallons of fuel, we can solve for k by dividing by 270. When you divide that on a calculator, you get a repeating decimal, but if we simplify this fraction, we can get it down to 2 over 45 for our k. Part of the problem that you need to do is to write the equation of variation. So that means you need to write the equation with the value of k in it. So that's part of my answer. Then you can use that equation to solve the question here. How many gallons are required for 400 miles? So G equals 2 over 45 times 400. If you multiply by 2 and get 800 and divide by 45, you end up with about 17.8 for that answer. The next question for the examples I'm going to show you is number 7, which is joint variation. Joint variation means you have some value, which equals some constant k times some other values. There can be multiple values that are multiplied after the k. Usually 2, but there could be more. So the value of real estate, V, equals k times the neighborhood index, N, and square footage of the house, which is S. So I have two variables over here. They give us some values to find k. 376,320 equals k times 96 for N and 1600 for S. If you multiply together these two numbers, divide this number by that result, you will get 2.45. Write your variation equation. So V equals 2.45 NS. Now we use that equation to answer the question. Find the value of a property with N is 83, plug that in here, and S is 2150. So V equals 2.45 times 83 times 2150. And on your calculator, that will give you $437,202.50. Okay, the next equation or example is number 12. This one is inverse variation. So that means you have your quantity equals some constant k being divided by some other constant, or other variable rather. So in this case, number of revolutions, let's use R for revolutions, is going to equal k over the number of the radius, the size of the tire. Small r radius. So they tell me that a 12-inch radius tire, that goes down here, makes 100 revolutions. I can multiply by 12 on both sides to get my k is 1200. Write the equation of variation. Y equals 1200, sorry, not y, r over radius. Okay, since I have the same letter, I'll just use the word. And then I can use that to answer my question. How many revolutions, what is r if my radius is 16? And I know that my k is 1200. So if I divide that, I will see that it is 75. That's inverse variation. The next example, number 15, is a combination of direct variation and indirect variation. So that means I have a quantity which is equal to a constant times another variable for the direct part, and then divided by something else for the indirect part. So they can be combined. So time is what I'm looking at, which is equal to some constant Varying directly with length, so L for length, and indirectly means divide by number of painters, so P for number of painters. 5 hours for 200 feet of fence with 3 painters. So if you multiply 3 times 5 and get 15 and then divide by 200, you get your K is 0.075. So write the equation of variation. T equals 0.075 times the length divided by the number of painters. Use that now to answer the question. How long means I'm finding time. I know my K is 0.075, 500 feet of fence, and I have 5 painters. So if you multiply and divide by 5, you will see that you have 7.5 hours that you need. One last example, just one slight variation. You can also have some of your variables being squared. So you drop something and the distance that it falls, so distance varies directly, so K times a quantity, but now it says the square of the time, so T squared. You can have exponents involved. So then it gives you a time and a distance. So for 8 feet, I have 1/2 of a second squared. Now that would be 1/2 times 1/2, which is 1/4. If you divide 8 by 1/4, it's actually multiplying by 4, and you get 32. So write your equation of variation. Get used to writing that. That is part of it. There's that. Then use that information. It says how long, so you're going to be finding T to fall 200 feet. So I know it's going 200 feet. I know that my K is 32. So there's distance equals K times the time squared. So I divide by 32. If I do that, I will get, reverse this, so I have T squared equals 6.25. And then if you square root both sides to get the solution, T equals 2.5 seconds. And that's it.